Hello, Honors Algebra students, Mr. Lawrence here, and this is the video I promised you called Factoring is Easy. Now, you can notice I put a chart together for you. I have it on that homework assignment, but here's the chart again, and I abbreviated it slightly different, but it's no big deal, it's the same stuff. So, if I have a binomial, the first thing I will always try is GCF, right? See it right there, the GCF, yes. And then I will try a difference of perfect squares. Okay, if I can't do either of those, the expression will be prime. It won't be able to be factored anymore. All right, maybe I can do GCF and not the difference of squares, or maybe I can do just the difference of squares if the GCF is only one. But anyway, I'm going to try those two things in that order, GCF first and then difference of perfect squares. All right, now, if I have a trinomial, three terms, first thing I'll do is try the GCF. Right? Then I'll check to see if it's a perfect square trinomial, and then finally I'll use the trinomial method. If all those fail, I know it's prime. All right, so let's take a look at this. On the homework last night, or on Tuesday night, I told you what the different types of factoring you'd probably be using. But on this one, I'm not going to. I want you to reflect back or look back on that chart and see what you can come up with. So anyway, just moving that out of my way here. And I'm in blue, I like it, good deal, I'm ready to go. Okay, so the first thing I do is look for a GCF, and I see one. I think I see a 2, so I'm going to factor out a 2. Now, when I factor out a 2, I'm left with a 25. What the heck is that? I don't know. Let's try to write that again. A 25 y squared minus a 9x squared. This problem is not done, because sitting in the quantity is a perfect square, 25y squared is a perfect square, and a 9x squared, which is a perfect square, and they're being subtracted. So this is the difference of perfect squares. So I'm going to have 2 times the quantity of 5y plus 3x, and the quantity of 5y minus 3x. And now I look inside the quantities. There is no GCF. There's no perfect squares. I know I am done. This is the completely factored form of the original problem. We call it problem number 1. Okay, very good here. I thought that would change for me. There we go. That's what I want, except I don't want red. I want blue. Okay, so let's try this one. Well, it's a binomial. First thing I'm going to try, GCF. I'm going to factor out a 5x. Going to make a mistake here. I'm going to get 2x. There we go. I'm done. What's that, Asim? You think I made a mistake? Right, I sure did. Not much gets by you, Asim. So I'm going to factor out the 5x here, which means there's going to be a 1 left. Right, a 1 left. By the way, I think my pen switched back when I picked up the eraser. Yep, it sure did. Well, it likes to revert to red. Okay. Now, I've got a binomial in the quantity, already GCF'd. There's no perfect square. I mean, 1's a perfect square, but 2x isn't. There's no subtraction. This is done. This cannot be factored any further. All right, let me see here. Where is my scrolling tool? Here is the next problem. It's not a binomial, it's a trinomial. Well, according to that chart, I'll try GCF first. And I'm thinking 3 goes into all 3 terms. So I'm going to pull a 3 out. And I'll have an x squared, a minus 2x, and a minus 24. Now, when a is 1, and I'm not worried about the 3, I'm only worried about the trinomial inside the quantity. When a is 1, this problem is too simple. I wouldn't list my factors of a and of c. On this one, I say to myself, I need 2 factors of 24. I need 2 factors of 24. That's subtract. How do I know to subtract? Because the 24 is negative. 2 factors of 24 to subtract, that equal negative 2. Well, right off the top of my head, I know it's 4 minus 6. So this inside here will factor very easily. First of all, since a is 1, I'll have an x and an x. And then I need a positive 4 and a negative 6. And I am done. All right? So, looking inside each quantity, I do have binomials. There's no GCF, and they're not perfect squares. 4 is, but x isn't, and 6 certainly isn't. So it does not work. We are done. Okay, here's just a trinomial. Go looking for a GCF. I only find a 1. Doesn't do me any good to factor out a 1, so I'm not going to waste my time. Because a is 1 in this one, I will ask myself, I need 2 factors of 15 that add to get positive 9. 2 factors of 15 that add to get positive 9. You know, I can't see them. There's no way I can add 2 of those and get 9. Guess what? This one's prime. Yeah, it's prime. You can't factor it. Can't be factored. Can't do it. Sorry, can't do it. All right, so. Okay, here we have a binomial. Looks like I better factor out a GCF. Why don't you pause the video and you give this one a shot? If you're still watching, I assume you've tried it already. I'm going to factor out the GCF. I'm wondering if I fooled you. Did I fool you? Because if you stopped here, you're not done with the problem. No, this quantity can be factored more. Yeah, it's a binomial. I already did the GCF. If it can be factored forward, it must be the difference of squares. It must be the difference of squares. So it's going to factor like 2x. Let's see, the square root of 16x to the 4th is going to be 4x squared. Right? So I'll have a pair of 4x squareds, and then I'll have a plus 1 and a minus 1. Don't you dare pick that pencil up. You're not done. You're not done. This can be done. This can be factored more. Yeah, it sure can. Whoop, where'd it go? Come back here. Come back. There you are. Okay, look. Inside this quantity, I got a perfect square. I got a perfect square. Oh, golly gee, there's no subtraction. This part is prime. This part is relatively prime. It cannot be factored anymore. The entire expression isn't prime, but this part here cannot be factored. But if I look over here, I've got a perfect square minus a perfect square. This part can be factored. So I'm going to have a 2x. I'm going to have a quantity of 4x squared plus 1. Then I'm going to have 2 quantities. Square root of 4x squared, 2x. 2x. Square root of 1. One of them's positive, one of them's negative. I check inside these quantities, already GCF'd. They're not. That's not a perfect square. 2x isn't a perfect square. 2x. So I am done. I don't have to worry about any other type of factoring because they were binomials inside the quantities. All right. I think that's it for the video. Tried to keep it short. Hopefully that helps you. All right, I'm going to sign off here. Mr. Lawrence signing off saying have a good night.